Welcome back to discussion on interference of light. In this session we will see Young's double-slit experiment and concept of fringe width, what is condition for bright band and condition for dark band. This concept we will see. Already we have learned in the last class interference of light. When two or more waves are overlap each other, their modification of intensity of the light takes place or redistribution of the light energy takes place. Redistribution means at some other point there is maximum energy of the light possible, that we are calling brightness, and at some other point minimum energy of the light possible, that we are calling darkness. So in the last class in theory of interference of light, that we have seen what is condition for bright band and condition for dark band. Already mean bright mean constructive interference and destructive interference. See. Now in this session we will see extended discussion on interference of light. Concept is Young's double-slit experiment. Using Huygens wave theory of light, Young's well explained interference of light by taking concept of wavefront. Already we know wavefront. So according to Huygens, wavefront is a locus where all medium particles are vibrating same phase. Here Young's double-slit experiment. Young's explained in detail the interference of the light. How to take interference of light by taking concept of wavefront. I mean by dividing wavefront, how wavefront can be overlap each other, as a result at some other point bright band possible and dark band possible. See here. Young's double-slit experiment consists of two slits. So one slit we are calling yes, and again another slit has provided two slits and a screen. Look at me. How this is? Initially, Young's has taken a rectangular slit which incident on monochromatic source of light. Let us take this slit I can call yes, this one I can call yes. Again he provided two slits. Let us call that slit I can take yes1. Look at me. I can take one more slit, I will take, say this is yes1, and one more slit you can call that is yes2, and a screen. Look at me. How this is? I can take, and I can take a screen. This is the screen. I can take. See here. This is the screen. And a monochromatic source of light. Where the monochromatic source of light? I can call this nothing but the monochromatic source of light. So let us take from this source so many waves are coming. Already we know that if the waves are going perpendicular to wavefront, see here, very simple arrangement. I can call, let us take monochromatic source of light. When a monochromatic source of light incident on the slit say yes, after passing the yes, so many wavefront divided and they get overlap each other. Look at it. I can take this nothing but the ray which is coming from monochromatic source of light. Say this we are calling ray. The rays they can incident at a different direction. Look at me. These are nothing but the rays. If rays are going like this, then how the wavefront will come? Look at me. This is the wavefront. This is the wavefront. This is the wavefront. This is wavefront. Are you following? This wavefront incident on the slit yes, so that they can divide, and incident on the slit S1 and S2. I can call this slit I can name as S1, and this slit I can mention as S2. Right or wrong? See here. How it is? Let us consider one wavefront. It will comes from the yes, and second wavefront it will comes like this, and again one more wavefront it will comes like this. This wavefront incident on the slit S1 and S2. Say after emerging from S1 and S2, those wavefronts act as a coherent. Coherent means they consist of same wavelength and same amplitude. Look at it. So this wavefront, how they will come? They will come like this. The incident on this slit. Let us consider one wavefront. It will comes from S2, and one more wavefront that will comes from S1. Right or wrong? Again, let us take again one more wavefront that is coming from S2. Again, one wavefront that will comes from S1. Are you following this? Then again, let us take again one more wavefront will come from S2 like this. Then again that wavefront will come from S1, and such that those wavefronts are overlap each other. Look at me. These wavefronts are overlap each other. Right or wrong? Then again, I can call again this is one wavefront emerging from this point. Right or wrong? Again from this one more wavefront will come in this fashion. Again, see here, again one more wavefront will emerge like this. They get overlap each other. Again like this, one more wavefront will comes and they comes like this. They comes like this. Like this wavefront will, our wavefront S1 and S2 which are coming from this S1 and S2 and they get overlap each other. So as a result, on the screen interference pattern is observed. How this is? Let us take from this point I can take this nothing but one ray of light, it will comes like this. Again one more ray of light that will comes from like this, and see here this is nothing but one more ray of light that comes like this. So on the screen in this region interference pattern observed. How it is? Look at me. Wherever this dotted line indicates, wherever two dotted wavefronts are intersect each other, where they are intersect each other, at this point they can intersect each other, at this point they can intersect each other, or wherever two dotted lines are intersect each other. Look at me here. Say this is nothing but one dotted line and this is one dotted wavefront, they can overlap each other. And some other points, the dotted wavefront can intersect with the solid wavefront. At this point they can wavefront, at this point they can overlap each other, at this point they can overlap each other like this. See here, this indicates that when solid line overlap with the solid line, I mean solid wavefront overlap with solid wavefront, their constructive interference possible. Whenever dotted wavefront overlap with the solid wavefront, the destructive interference possible. See here, this interference pattern that consists of a central bright band and followed by dark band and bright band on each side. See here, how this is? At the center, I can call this center point, I can call say this is nothing but O point, and at this point there is interference pattern observed. That interference pattern consists of central bright band. I mean at this point there is maximum intensity, followed by what? Again it consists of dark band of equal width. This is the dark band again. At this point again it consists of the dark band, again represented by like this. So again here bright band is possible. Again at this point bright band is possible. At this point again dark band is possible. So can represent like this, dark band. At this point dark band is possible like this. So interference pattern, it consists of a central bright band followed by dark band and bright band. See here, again here bright band is possible. Again here bright band is possible. Very simple. I mean after dividing the wavefront from S1 and S2, they get overlap each other. As a result, on the screen interference pattern observed, that interference pattern consists of central bright band followed by dark band, bright band. Again dark band and bright band. See here, he observed that the intensity of the all bright bands are same. Intensity of all bright bands are same, along with they have the same width. They have same width. The width of this bright band depends on intensity of the light terms. Similarly, the dark band has a zero amplitude, dark band has zero intensity, and they have the same width. See here, this dark band consists of same width and bright band consists of same width. Bright band consists of maximum intensity and dark band consists of zero intensity. See here, it indicates that maximum intensity means wherever crust is overlap with crust or trough is overlap with the trough, their maximum intensity possible. Wherever crust is overlap with the trough, their minimum intensity is possible. And look at me, distance between any two bright band or distance between any two dark band, this we are calling fringe width. This we are calling fringe width. Fringe width mean what? Distance between any two bright band or distance between any two dark band or distance between any two consecutive bright band or dark band, this we are calling fringe width. Very simple. Hence has taken the interference pattern by taking the concept of two slits. Say this we are calling double slits. And let us take a rectangular slit which is incident by monochromatic source of light. After emerging from the wavefront get divided from S1 and S2 and they get overlap each other. So the interference pattern is observed. See here. Then we need to see the concept of fringe width. I said distance between any two dark band or distance between any two bright band we are calling fringe width. Now we have to see what is expression for fringe width. That concept we will see now. Look at it. After this we will see expression for fringe width. See here, already we obtained how interference pattern is observed by taking Young's double slit experiment. See here, look at it. Now after this fringe width, expression for fringe width. Expression for fringe width. Expression for fringe width. See here. To explain this, now we have to take two slits. See here how it is. Now I can take this nothing but two slits. I will take double slits. I will take. Let us take its name is S1 and S2. I will take. See here. These are two slits. Shall I call? So this slit I can name as S1 and this slit I can name as S2. Right around this. This is nothing but midpoint of two slits. Now I will take a screen. Look at me. This is screen I will take. This is screen where interference pattern is observed. Look at me. Now consider one ray of light. See here. This is nothing but one ray of light that is incident from S1 and meet at P. Meet at P. Let us consider it is meet at P. Correct or wrong? Again, one more ray of light that will come. One more ray of light that is incident from S2. Again, they will meet at point P. Let us consider this ray of light. It will meet like this. Right or wrong? I can take this midpoint. Say this midpoint I can call this is N point. I will take, or you can take D point. Look at me. This is nothing but midpoint. From this midpoint, I will draw the line. So it meet at O. Right or wrong? Then again I will draw the one more line from D that is meets at P. Meets at P. See here. Consider two slits. They have separated by small distance. I mean distance between two slits I will represent. That is represented by small d. Actually behind it one more slit is available. That is S. From the S this wavefront will comes. Then see here. These we are calling slits and this is the screen. Distance between slits and screen that is represented by capital D. Distance between slits and screen that can be represented by capital D. Look at me. All the wavefront that will comes from S1 and S2 they can overlap each other. As a result, interference pattern is observed on the P. At P either bright band possible or dark band possible, but exactly at O central bright band is possible. See here. This central bright band from the point P it is available somewhat distance. That distance I can represent by X value. Shall I take? X is what? The distance of bright band from point P. At point P, what you can say? At point P, you can say either bright band is possible or dark band is possible. But exactly at O, what is possible? Bright band is possible. Then, we know fringe width. How to define? Distance between any two consecutive bright band or dark band we are calling fringe width. Initially, shall I write the definition? The distance between any two consecutive bright or dark bands. Distance between any two consecutive bright or dark bands. Bright or dark bands is called as fringe width. Is called as fringe width. Is called as fringe width. See. Now we need to know what is path difference between S1P and S2P. Path difference between S1P and S2P. See here. If we draw a perpendicular line from this, shall I draw a perpendicular line? If I draw a perpendicular, say I will draw Sn perpendicular to S2P. Sn perpendicular to S2P. Shall I take? This is Sn perpendicular to S2P. I need path difference. See here. From this S1P is one ray, S2P is one ray. Then what can path difference? Path difference between two waves can be represented by del x. What is path difference? S2P minus of S1P. In this one S2M that represent path difference. S2P minus of S1P. Then see here. So in this figure, two triangles are looks like. Shall I take? I can take this is nothing but S2, and what about this? This is S1. Simply this is S1. Here some angle available. I mean this S to N, what you are taking, this is nothing but path difference. S to P, S1 starts from this point but S2 starts from this point. In between S1P and S2P, what is difference? S to N is the difference. Again, in this triangle. So in this triangle S1, S to N, which is angle? This is angle, I can take theta. Right. Then in this one more triangle looks like the DPO looks like one more triangle, that is represented by what? Well, again that is represented by theta. Students, already we know in optics, whatever angle of incident and whatever angle of reflection, those are assumed to be very, very small. Whatever sine of angle, whatever tan of angle, that is assumed to be very, very small. Remember this point. Then again we need to know some angles. Look at in this triangle. In this triangle, which one is triangle? S1, S2, N is one triangle. In this triangle, this is theta available. Theta. Then shall I take sine theta? Sine theta is equal to opposite is equal to del x, that is S to N. Or for my convenience I will take what value? That is S to N whole divided by S1, S2. This is one triangle, this is one triangle, right? Then see here, for my convenience I will take this point is D, small d I will take, or for my convenience I will take this point. To avoid, I can take this is nothing but Q value because their notations are same, right? Now S to N is del x, sine theta nearly equal to theta, because whatever angle of sine of angle of incident, sine of angle of refraction, those are assumed to be very, very small. So theta is very, very smaller. Then S to N, that is represented by del x, S1, S2, that is represented by what value? Small d. Now shall I call this is the equation number 1? One more triangle. QPO looks like one more triangle. See here, triangle QPO looks like one triangle. In this triangle I will take tan theta. See here, how to take tan theta? Tan theta is equal to opposite is equal to PO and adjacent is equal to QO. Again theta is very, very smaller, tan theta nearly equal to theta, so that theta is equal to PO is equal to x value. X mean the distance of bright or dark band from central bright band, and this OQ nearly equal to capital D, distance between screen and slit, right? Then now I can take this as equation number 2. Compare equation 1 and equation 2. What we'll get if we compare this? Then directly I can take del x divided by small d is equal to x divided by capital D. Or how to take from this? From this I can take again directly. See here, x is equal to what value? X is equal to del x into capital D whole divided by small d. See here, at P point either bright band possible or dark band possible. Then we will see condition for constructive interference or bright band, or condition for dark band or destructive interference. See here, this is what general expression we got. See here, now can take condition for bright band. Condition for bright band, or we are calling constructive interference. Condition for bright band. Look at me. For bright band we know, or for constructive interference we know path difference. Path difference between two waves must be equal to integral multiple of n lambda. See here, for constructive interference or bright band, x can be replaced by xn and del x can be represented by n lambda, where n is equal to 1, 2, 3 or 0, 1, 2, 3, 4, 5 like this. See it. Then I can take directly, if n is equal to 0 means central bright band possible, n is equal to 1 in first bright band possible, n is equal to means second bright band possible, like this I can take. See here. Then from this I can take this condition, xn is equal to what? Well, x is equal to xn, del x is equal to n lambda into capital D divided by small d, like this. See here. Now for first bright band, xn is equal to x1 and n is equal to 1. Then how it is? First bright band x1 is equal to, that is lambda d divided by small d. This is first bright band. Then for second bright band we will see. For second bright band, xn is equal to x2 and n is equal to 2. See here. Then again take. How to take? X2 is equal to, that is 2 lambda capital D divided by small d. We got x1 value, it is first bright band, and we got again second bright band, that is represented by x2. What is actually fringe width? Difference between any two bright band or difference between any two dark band, that we are calling fringe width. Look at me again from this. See here. How to take then actually fringe width? Fringe width is difference between any two bright band, that is x2 minus x1. x2 minus x1. x2 is this value. X is equal to 2 lambda capital D divided by small d minus of lambda capital D divided by small d. Then what is expression for fringe width? Expression for fringe width is equal to how much? That is lambda d divided by small d. This is what? Expression for fringe width. Then for n bright bands, for n bright band we should take this equation. N is equal to 1 first bright band, n is equal to 2 second bright band, n is equal to 3 third bright band, like this. Like this you can take number of bright bands. See here. So this is condition for a bright band. Condition for bright band. Then similarly you can take condition for dark band. Simply you can take the path difference can be represented by 2n plus 1 lambda by 2 and xn is equal to x is equal to xn plus 1. If you take x is equal to xn plus 1, then del x is equal to 2n plus 1 lambda by 2, that represent condition for dark band. So either you can represent, this is bright band. Shall I explain how we will take the condition for dark band? See here, this is condition for bright band. Look at. Then now we will see condition for dark band. See here, how to take condition for dark band. Condition for dark band. How will explain that? See here. For dark band already we know path difference. Path difference must be equal to 2n plus 1 lambda by 2. See here. How to take path difference for dark band is equal to 2n plus 1 into lambda by 2. Already we have seen in the last class. Right. And for dark band that x is equal to xn plus 1. So put this value. X is equal to xn plus 1 we will put. X is equal to xn plus 1 we will take, and del x is equal to 2n plus 1 into lambda divided by 2d. Right. Now simply. Now can take n is equal to 0, n is equal to or n is equal to 1, n is equal to 2, like this you can take. No matter, for example I can take n is equal to 1. First dark band I will take. x1 is equal to what value? x1 is equal to xn plus 1, and for n is equal to 0 I will take. Look at me, n is equal to 0 I will take. Then what it is? First dark band, x1 is equal to, see here, this is 0. Then what is remaining? Lambda d divided by how much? 2d. Right or you can put like this also. Say take n is equal to 1. N is equal to 1 mean put n is equal to 1, then x is equal to x2 and n is equal to 2. What about this relation becomes? See here how this relation becomes. x2 is equal to 3 lambda d divided by 2d. What is fringe width actually? Difference between any two dark band. There last we have seen difference between any two bright band. Look at me. What about this equation then? See here, x is equal to much? x2 minus x1. X is equal to 3 lambda capital D divided by 2d minus. See here, for my convenience I will take like this. See here, shall I write here? X is equal to xn plus 1. I can write here only. See here, n is equal to 2. N is equal to 2 and x is equal to x2. X is equal to x2 or xn plus n is equal to x2. Then what it becomes? See here. This I can write directly. How to take? x2 is equal to 3 lambda capital D divided by 2d. Right or wrong? I can take fringe width. Fringe width in what? Difference between any two dark band. That x is equal to how much? Shall I remove this? X is equal to how much? X is equal to x2 minus x1. x is equal to x2 is this much 3 lambda capital D divided by 2D minus of this value lambda capital D divided by 2D. So again you will solve, same value will come. How much? Lambda capital D divided by small d will come. This is what? Condition for dark band. This is condition for bright but dark band, and last we have explained condition for dark band. Simply difference between n into bright band or difference between n into dark band, that we are calling fringe width. Let's see here. This interference pattern is said to be sustained. Interference pattern is sustained if the case interference pattern doesn't change with the time. See here. Now after the second take, are you getting this? So this we are calling what? Condition for bright band and dark band later on. See here. Now simply I can remove this, then we will see condition for sustained interference, and we will see path difference and phase difference condition. Very simple. See here. After this you can see sustained interference. Sustained interference. Look at me. We got this equation. What we got? We got x is equal to lambda capital D divided by small d. Are you following? Expression for fringe width. So if n is equal to 1, put n is equal to 1 here, or in terms of nth, I can take x nth is equal to n lambda capital D divided by small d. See here. Interference pattern is said to be sustained if the case interference pattern doesn't change with the time. For sustained interference, what is condition? See here. For sustained interference, the source of light, whatever incident on S1 and S2, that must be monochromatic. That must be monochromatic. I mean, monochromatic mean along with it must be coherent source. See here. To get the sustained interference in between O and P, the ray of light must be monochromatic and coherent. Monochromatic mean it contains single wavelength. It must be contain same amplitude. It must be contain same wavelength. So that. What is first condition? For sustained interference, source of light should be monochromatic. Should be monochromatic. And second one, the source of light must be coherent. Coherent means contain same wavelength, same amplitude. Can see here. To get the maximum bright band, this value should be smaller. If this is smaller, what is extent? That should be increased. If this is larger, then this should be increased. Then what is condition? See here. To obtain sustained interference and well defined interference pattern, distance between two slits must be very smaller. Distance between two slits must be very smaller. See here. Third condition you can take. Distance between any two slits. Distance between two slits must be very small. And fourth one, distance between screen and slit. Distance between screen and slit should be very larger than well defined interference pattern is observed. Then I can take distance between slits and screen should be large. This is condition for sustained interference. Then I can take condition for maximum intensity and condition for minimum intensity. What is ratio of condition for maximum intensity and condition for minimum intensity? To understand this, we should know actually when at the point P, either bright band possible or dark band possible. When bright band possible? When two waves of same wavelength, same amplitude intersecting at point P, such that at point P bright band possible. Bright band possible means crust of the one way overlap with the crust of another way, or trough is overlapping with the trough. See here. When crust is overlapping with the crust, then what is actually resultant amplitude? Resultant amplitude is equal to what value? A1 plus A2. Here two waves are coming. See here, this is one type of wave. How it is coming? It is coming like this. It has what value? It has amplitude of A1. Then what about the second wave is coming? What about amplitude? That is represented by A2. At point P, when crust is overlap with the crust, then amplitude can be represented like this. Similarly, how the intensity of the light is there? Intensity of the light, A directly proportional to what value? Intensity directly proportional to square of amplitude. For a maximum intensity I will take, see here, then I directly proportional to what value? I directly proportional to A1 plus A2 whole square. This is what condition for maximum intensity. Shall I take directly? Condition for maximum intensity I will take. Condition for maximum intensity I can take directly. I maximum is equal to how much? A1 plus A2 whole square. Because R is equal to R1 plus R2, I directly proportional to A square. See here. Then you can take condition for minimum intensity. Shall I remove this? Look at me. I can write here only. See here. Two waves are overlapping each other. Then resultant amplitude can be given. I is equal to A1 plus A2 from equation intensity directly proportional to square of amplitude. Right? Then how to take the intensity? Intensity is equal to A1 plus A2 of whole square. What you are taking this? Maximum intensity. I can take this is maximum intensity, so it is equation number 1. If the case two waves are overlapping each other such that crust is overlapping with the trough. When crust is overlapping with the trough according to superposition principle, then what is amplitude? Amplitude is equal to A1 minus A2. So that again from theory intensity directly proportional to square of amplitude. Wherever amplitude subtracted intensity is very smaller. Intensity directly proportional to square of amplitude, directly I can take minimum intensity. What is minimum intensity? Minimum intensity is equal to A1 minus A2 whole square. So you can call this is equation number 2. Now take ratio of maximum intensity to minimum intensity. How to take maximum to minimum? See here. Ratio of maximum intensity to minimum intensity. You can represent by A1 plus A2 whole square whole divided by A1 minus A2 whole square. This we are calling ratio of maximum intensity to minimum intensity. Similarly, this width of the slit, that also directly proportional to square of amplitude. How much intensity is there, that much width also available. This is interference pattern, Young's double-slit experiment and fringe width. Numerical on interference of light. Young's double-slit experiment, that we will see in the next session. Thank you.